Welcome again to another one of my mathematics tutorials. In this session, we will be looking at the different types of sets. Remember, sets in mathematics are an organized collection of objects based on common characteristics. Now let's have a look at some of the different types of sets. Okay, so a finite set. This is a set where all the elements can be counted. For example, factors of 8. I know the factors of 8 are 1, 2, 4, and 8, and I can all list them. So once a set can be listed or all the elements can be counted, it is considered to be a finite set. Let's look at what an infinite set is. So an infinite or infinite set, this is a set where all the elements cannot be counted. For example, multiples of 8. I cannot list all the multiples of 8 because it goes all the way to infinity. So I can list some of the elements of the multiples of 8. So I will say 8, 16, 24, 32, and the list goes on. So I have my 3 dots there to show that the list goes on. And that is called an infinite or infinite set. Okay, so next we have equal sets. 2 or more sets are equal if all the elements are exactly the same. Let's take 2 sets for example. A is the set of letters of the word rats, and B is the set of letters of the word star. Now, each one of those letters are the same, right? So the letters of the word rats is the same letters of the word star. So these 2 sets, A and B, are said to be equal. Now it doesn't matter the order in which the elements are written in the set, once all of the elements are exactly the same. So we use the equal sign to denote equal sets. Now let us look at equivalent sets. 2 or more sets are equivalent if they have the same number of elements. Let's take for example 2 sets C and D. C is the set of letters of the word pants. So I have P, A, N, T, and S. And D is the set of letters of the word plate. P, L, A, T, E. Now notice that each one of those elements are not exactly the same as the other elements of the other set, right? But what we do have is that both sets have the same number of elements. So I have C having 5 elements and D having 5 elements as well. So I can say that C and D are equivalent sets, and this symbol here is used to denote equivalent sets. So once 2 or more sets have the same number of elements, they are said to be equivalent sets. Okay, so null or empty set. This is a set that has no elements. So for example, months of the year starting with the letter Q. I know that there are no months of the year that start with the letter Q, so therefore that is an empty or null set. And we denote null sets using 2 curly brackets without anything inside. Now we need to pay special attention to this here. If 0 is inside the curly brackets, it is not an empty set. 0 is going to be an element of that set. Remember, 0 is a number. So once you have anything inside that curly brackets, it's considered to have some sort of elements in it, right? So to denote a null or empty set, it is simply 2 curly brackets without anything in it. Subset. Now, a set where all the elements are contained in another set is called a subset. For example, let's say we have two sets E and F. E is the set of whole numbers less than 10 and F is the set of factors of 8. So what I did is that I listed out each one of the elements of both sets. So E, which is the whole numbers less than 10, E is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the whole numbers less than 10. And F is going to comprise of all the factors of 8, which is 1, 2, 4, and 8. Notice that all the elements of F is completely included in the set E. So 1, 2, 4, and 8, I can find each one of those elements in the set E. And therefore, F is said to be a subset of E. So the symbol for subset is this symbol here. And because F is completely included in E, I will say F is a subset of E, and therefore I will write this. F is a subset of E. So next we move on to disjoint sets. Two or more sets are disjoint if they have no common elements. So for example, let's take G and H, which are two sets. G is the set of factors of 10 and H is the set of whole numbers between 10 and 13. So I have listed the elements of both G and H there for you. G, which is the factors of 10, are 1, 2, 5, and 10. And H, which is the whole numbers between 10 and 13, are 11 and 12. Notice those two sets have no common elements. And as such, those two sets are said to be disjoint sets. Now let's look at the last type of set that we are going to consider, the universal set. This symbol here, which is a U, or this curly looking E, are two symbols that is used to represent a universal set. Now, this type of set is a set of all members being considered that is suitable for the question. Now, let's look at an example to fully understand what a universal set is. So let's take three sets, A, B, and C. A, which is the factors of 9, B, odd numbers between 1 and 20, and C, multiples of 2 less than 25. Now on the side here, I am going to write out what those elements are. So factors of 9, 1, 3, and 9. Odd numbers between 1 and 20, that's going to be 3, 5, 7, 9, 11, 13, 15, 17, and 19. Next, multiples of 2 less than 25. So it's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Right? So those are the elements of those three sets. Now, what can be a possible set or a possible universal set that is going to include all of those numbers? I have came up with a set here, which is whole numbers less than 25. Is that going to include all of those numbers there for those three sets? Yes. Whole numbers less than 25 starts from 0 and then goes 1, 2, 3, 4, 5, 6 all the way to 25. And if you look in those three sets, all those elements are included in that universal set, whole numbers less than 25. Now, I'm not going to come up with a universal set like all the counted numbers, right? Because that is going to be, that is not going to be suitable for this question because I'm only considering really numbers that are less than 25. So I'm not going to write the universal set as all our counted numbers, right? So a universal set must be appropriate or suitable for the question. So when choosing that universal set, you have to look at all the elements in the set and then determine what your universal set may be. So that's it there for the different types of sets. Thanks for joining me.
Don't forget to like, share, and subscribe for more of my videos.